all the time. All right, friends, we're going to cruise on to our next presentation. Our next presenter joins us from the world of Zoom. So we're going to get Louise Hardman online, presenting on plastic and recycling in remote communities. Louise, can you hear me okay?
Yes, I can. Can you hear me?
Yeah, we can. And that backdrop looks lovely. Where is your backdrop from?
Yeah, that's where this is where I live. This is Mulloway. So I'm
Perfect.
northern New South Wales, north of Coffs Harbour.
All right. And what's the weather actually like there at the moment?
Oh, beautiful. Yeah, no,
Oh,
very
yeah.
calm today. No rain, no wind, but a bit chilly. But it's
Bit
nice.
chilly. Yeah, beautiful. I reckon less than 20 degrees.
Yeah, somewhere around
Yeah.
15, I think. Yeah.
I'm a
But
bit
I do,
skeptical about calling that beautiful, to be honest, but that's just me being a Darwin girl.
yeah.
Um, so I'm going to hand over to you. Did you have a presentation or something that you were going to screen share with us?
Yep, yep, I do. Um,
Excellent.
I'll just get,
Well, I'll let you get that up, and maybe what I'll do is I'll get everyone to put their hands together and give a tropical round of applause for Louise Hardman. Everyone.
okay. Thank you very much. Okay. Okay. All right. So I'm assuming you can still hear me. So yeah, thank you everybody for having me, and I'd like to acknowledge the traditional owners of Larrakia, past, present and future, and also from our region, which is the Gumbaynggirri region. Um, so I have a business called Plastic Collective. Our aim is to transform remote communities by eliminating waste plastic. So today I just wanted to present plastic neutral pathways for council. I've been thinking about this for a while, and I believe we've got quite a good option here for councils. So as we all know, landfills are quite toxic and dangerous. They pose serious health risks to people and wildlife. They've got long-lasting environmental contamination of soil, air and water. And they also incur significant economic loss from unrecovered materials, particularly organics, plastics and other nutrients, as we call them. So air pollution, often many landfills are typically burnt in remote and regional communities. We've been working in a lot of regional communities, and we've seen this quite often to reduce the volume. You know, once they overflow, they tend to burn them to reduce volume. Water pollution or mixed waste creates toxic compounds, leak into the groundwater, waterways and oceans. Soil pollution from leachate from the dump site enters the soils, also leaking into groundwater, causing contamination, killing surrounding plant life. And greenhouse gases are also quite significant. They estimate about 32% of the methanes and the greenhouse gases actually coming from landfills worldwide. Increase when the organics and the plastics are mixed together and unable to rot properly. And harmful pathogens from diseases from rotting food, plastics which damage human and animal health. So in knowing all this, I started looking at how are we going to fix this problem? So the first thing was looking at what our attitudes are. What's waste management? Should we be thinking about waste management or resource recovery? So part of our education and training is to work with communities to understand how to eliminate the concept of waste and how to look for value in materials. So we often don't call it waste management. We do focus on calling it resource recovery for that reason. When you look at the number of waste management facilities around Australia, the small black dots are landfills. There's estimated over 600 official landfill sites and another approximately 2,000 or more unofficial or illegal landfill sites. I know for a fact that there's a number of sites in here that are not on the map. So, you know, there are a lot more. And when we compare these waste sites to resource recovery facilities, there's quite a stark difference. So for that reason, we're sort of trying to eliminate the waste fill areas. So Plastic Collective, our goal is to empower regional and remote communities to establish plastic resource recovery programs, which will eliminate waste, as I mentioned, and create local economic opportunities, products and employment. This was recently just got back from the Gulf of Carpentaria, where we're working with the Land and Sea Rangers there and Earthwatch. I'll explain that one a little bit more as we go. Bit of a background with Plastic Collective. So I founded Plastic Collective in 2016. My background is I'm a zoologist and high school science teacher doing environmental education. It started when I found a turtle that had ingested plastic and died after 3 days. So that was the kickstart to this business. 2018-19, we delivered 3 remote Shruder pilot programs to Whitsundays, North Bali, Mantanani. A Shruder is a small mobile recycling machine, a shredder extruder combination that we built over these between 2016-2018, which I'll show you in a minute. In 2020, we've received a $5 million federal government grant to develop plastic resource recovery solutions, particularly for remote and regional and Indigenous communities, to upgrade our previous Shruder concept into something that's a lot more comprehensive. In 2021, which this year, we're currently delivering what we call the Shruder Recycling Station, or the Plastic Collective System, SRS, to Indigenous communities of Barraville, Normanton and Burketown, as well as over in East Java to communities over there. Some of our partners include Earthwatch, Southern Cross University, National Marine Science Centre, South Pole, and 3R Initiative with plastic credits, plus some others. So the first Shruder, what we call the version 1 Shruder, which was, I think you can see in all of the photos, that's the shredder extruder machine that weighs approximately 150 kilograms, and it creates products for the communities. We run an education training program with it to empower the communities to understand what plastic is as a material, how to separate it, how to sort it into the different types of materials, and how to reprocess it, and also looking at supply chains. So the first ones we did was Whitsundays, Northern Bali, Malaysia, with Reef Check Malaysia. And yeah, each of these communities were a not-for-profit, and they were doing fantastic work within their community. And we brought these machinery and training programs in to help them eliminate their waste and their landfills, which we did quite well, but there was some things that needed improving, which this is why we came back and started redesigning the system. And this is where we got to when we came back from the version 1. We started developing the comprehensive solution, what we call Plastic Collective System. And that includes small-scale plastic recycling facility that processes plastic waste into valuable products, mostly shred, extrusion, compression mold, which could make things like building products, small chemical recycling units. So in summary, basically we have hardware equipment. We also have digital infrastructures with sensors and apps. I've got a very comprehensive education and training modules that cover materials, resource recovery operations, enterprise essentials, and also education for the community. We've also been working with the 3R initiative, which is a global plastic credit certification that was launched February this year. And you get collection of manufacturing credits, which I'll explain a little bit more. And then we've also developed an ethical environmental compliance program or system that sits around all of this to enable us to track the materials from the source, from when it leaves the communities, all the way to when it gets to the companies and the brands. And this provides a verification, but also enables communities to sort of get additional credits for those. And a dedicated supply and marketplace, which we provide support with. So just I'll go over this quickly because this is one of the most asked questions. What are the plastic credits? Basically, our company now it's run by my family, my brother and my sister and we run it. My brother's over in London. He runs the plastic credit side of the business, and he gets funding from the corporations who offset their plastic credits. So basically, we match the buyers to the sellers. So it's very similar to carbon credits, where the brands they'll reduce as much plastic as they can and try to redesign their products as required through the Ellen MacArthur Foundation and other global commitments. And then what they're left with, often they can offset that, and as long as it's verifiable and it's been verified by independent accreditation companies, which includes South Pole, which we work with. So basically those funds go to set up these community projects. We've been upgrading our version 1 projects over in Bali with Sundays with credits at the moment to make them more, to make them work better. And we're getting we just got additional funding to set up a project in East Java, which all came from credits as well. So the current version 2 SRS project. So this is one of our containers with some of the equipment in it. We have education training programs embedded within the containers or within the training. We've got 3 that are currently in just about to be delivered. So one is Mimi Aboriginal Corporation in Barraville. We have partners Gowings Whale Trust there and Midwest Forum. And that's being set up at Barraville Buttery, and that will be called the Centre for Sustainable Solutions. We're working with we've just set up a new land and sea ranger program there as well through the DPI, which is really exciting. First one in New South Wales, I believe. With the Carpentaria Land Aboriginal Council, CLCAC, up in Burketown and Normanton. We working with Coca-Cola Australia Foundation, where we got funding for Wetlands Not Wastelands project, and Earthwatch has partnered with us. So we recently came back and did our first training, which is teaching 21 rangers material science around plastics and looking at curbside materials and also fugitive materials, which is the marine debris and the materials that have escaped into the system. The third project is the Leaf Farmers Resource Recovery Program in Jemba, East Java, and our partners there are Philip Morris International, where they grow tobacco leaf, and they have they buy their leaf from the farmers, and Pertiwi Consulting. So we're delivering that project remotely with partners in Indonesia. So we work really closely with them on that one. So all 3 of these projects are slightly different depending on their needs. For example, the golf project won't be delivered in a container. It'll be different types of equipment because they already have facilities, whereas the Leaf Farmers project, that will be delivered as what we call a hub and spoke model. So just to explain the hub and spoke model. So the idea of setting up these resource recovery programs is to take the solution to the problem rather than trying to bring the materials to one place. So in doing that, we started off by sort of taking small remote, small machineries to these remote communities and found the volume just wasn't there. So we needed to build up the volume. So we've developed this model, which is more based around hub and spokes and collection sites. So this is what we're doing over in Bali, right in East Java right now. So one hub could be an existing manufacturing company that produces products. The spokes are introducing balers, basically concentration. So it could be balers and granulators that concentrate the material down, reduce the volume and increase the amount of material that can get to the hub. But they also, at the collection sites and also the spoke sites, they also go through material separation. So they do very good source separation, which increases the value considerably once it gets to the hub and there's no contamination. So one of the very interesting listening to the nappy lady, which I really, really appreciate because I've seen so many places with nappies lying around that cause so much damage. Contamination with organics, biological and technical nutrients is one of the biggest problems in recycling. So if we can reduce that and educate people that, each biological should be separated from technical, which is your plastics and your other recyclables, then you've got a lot more chance of getting maximum recovery. So to go into what our PC approach for the remote local government areas, a 3-stage process could be to recover plastic materials and eliminate waste. To eliminate toxic waste, creating economic enterprises. We basically go through 3 phases. So the first stage, which we're doing the first stage in all of our projects right now, recover the polyolefins. So your polyolefins are your polypropylene, polyethylene, your PP, HDP, LDPE, which represent around about 50 to 60% of all the plastics. And once you take out the PET bottles, which usually are collected, the first thing to be collected through the container deposit scheme, then what's left over is mostly polyolefins. So the reason why we sort of started focusing on these was that they're easy to recycle. They've got good value. They're not toxic. They're not like PVC or polystyrene that can cause problems. And they're just, they're easy to work with. So the first part is basically sort of, actually, I'll jump into that in a minute. Second stage is manufacturing products. So using these polypropylenes, polyethylenes into making local products on site. And the third stage is when you really want to remediate your landfills and eliminate the soft plastics or your multi-laminates and other things that are very difficult to recycle. Moving into a pyrolysis chemical recycling, is a very good solution to get fuel oils such as diesel, kerosene, and other things that may be used in a local community, and also reduce their reliance on importing those fuels into their community. So the first stage, the recovery of polyolefins. So if we look at it, polypropylene's got a recycling rate of 2% in Australia. HDP is around about 15%. We've got companies at the moment asking for 200 tonnes of polypropylene a month that they could make into products. Polypropylene is one of the most important products that's used in the automotive industry, and we're sending it all to landfill right now. The company that we're working with, they import it from Taiwan at $1,500 a tonne because they can't find recycled polypropylene in Australia. So these represent about 50% of single-use plastics, those 3 combined. In the training programs, we go through very detailed source separations, including going into plastic forms and resin types. Essentially, that's to ensure that we can guarantee the melt flow index, which all manufacturers need to know when they're making something. That may be because it's made from injection blow mold or extrusion blow mold. Different forms will have different melt flows. The equipment stack is basically granulator, air extractor, some digital apps, and environmental sensors that we include. And the capacity of these machines, this has gone up into 3-phase version 2, I should say, is up to a tonne a day. So you can really, process a lot more material and make it more economically viable. And in addition to that, when material is granulated, it can attract 2 credits. One is a collection credit and the second is a plastic manufacturing credit with the right compliance and verifications. The setup costs under 80,000 with R&D's being completed on this now. And potential revenues from the shred sales at this rate is around about, under 400,000 per year plus credits. Stage 2, actually I should say this hand plane that's here is one of our customers. He buys the material from us from our Whit Sundays project, and he makes these hand planes with it. So that hand plane is made out of 30% ocean plastics, 70% curbside plastics. Okay, so stage 2 manufacturing of products. The manufacturing recycled products using extrusion, compression, mold, it can provide very valuable locally made products and businesses. So the mechanical recycling process, extrusion, press molding or compression mold of thermoplastics, same polypropylene, polyethylene. The equipment used for this is extrusion machines, compression molding with approximate capacity of 50 tonnes a year. The product output we're basically working with Southern Cross University at the moment with polymer scientists developing products, including polypiping, fence post, decking, building, different building and agricultural pieces that, fit into a design matrix that we have. The income potential, we are aiming at minimum sort of $5 a kilo per product, which would generate around about $260,000 a year, plus manufacturing credits, which may vary depending on the supply and demand as well. So the cost for these 2 units, under 120,000. The R&D is almost complete, due to be completed by the end of this year. The third stage, chemical recycling. So these are containerized, self-sufficient, and EU certified waste plastic to fuel recycling. This is a pyrolysis process, which is absent in heat, has no oxygen, sorry. It's got no oxygen. It heats to around about 500 degrees. It gasifies the plastics and then recondenses it, or condenses it, the plastics back into fuel oil. So depending on the recipe of what materials go in, the lighter plastics will create more lighter fuels like gases and kerosenes, whereas the heavier ones like polystyrene, they will produce heavier diesels, unleaded diesels, and a certain amount of char, as well as some grease. So all hard plastics and soft plastics can be used, apart from PVC, and preferably not PET either. Product yield of about 80%, and we've got the outputs here. The machinery equipment is, it's called the Beetle. It's a South African manufactured machine, and it's currently being tested in Australia with an Australian company that will be distributing them once the R&D is complete. So we're looking at working with them. The processing capacity is around about 600 kilograms a day, or 156 tons of fuel oil produced per year. The cost of setup is under 350, and potential revenue per year around 200,000. So as I said, the R&D is underway with this. We've been looking for small sort of mobile pyrolysis units that do have a capacity of about 100 kilograms per hour. And this is one of the better ones that I've seen so far. We've been looking at different ones. So when we look at the value of the community resource recovery system, basically projects will not survive if they're not economically beneficial and they don't provide real value for the community. So these costs below, these are estimates. There's quite a few assumptions in here. As each project that we do, we go through detailed project planning and financial modeling to make sure that it's going to work before we launch into developing and sending equipment to different places. But in a nutshell, basically, with one of these systems, you may be able to process around 468 tons of plastic per year, which would represent around about 20,000 people based on 40 kilograms per person per year. And that's where the hub and spoke model is very handy, where you can bring in material from different areas, and it can be an entire regional project. The cost of setting it up is under 500,000, or sorry, just a bit over 500,000, depending on what's needed. The landfill savings is around about 40,000. That's based on New South Wales landfill costs, and transport savings will vary depending on location and distance of what's currently being, in operation. Plastic credit income would be around about 312,000, depending which credits they get. And the commodity from income would be about 825,000 based on grind and polyolefin manufactured products on site. So that's my talk. Thank you very much. I'm Chief Engagement Officer Louise, and if anybody wants to contact me, I'd love to hear from you.
Great, thanks. Can we please put our hands together, and thanks, Louise.
Yes, you're welcome.
Were there any questions from the audience today? Yep, there's one. I'll just walk the microphone over.
Yes.
So what products do you make out of the extruded plastic that you get?
Yeah, what products do we make? At the moment, we're doing polypipings. So the university, we're working with polypiping, building products such as, footings, building footings, decking. Yeah, so they're running through a number of things at the moment. That's a research project that's happening at the SCU University at Lismore. So at the moment, they're trialing a lot of different things. Yeah, and it's in development still.
Yeah, it looks pretty good, the setup. Yeah, for sure.
Yeah, sorry, I should say one of the projects, we've got two master's students working on that at the moment. One of them is looking at fire retardancy in recycled products. One of the problems is if you put fenced posts in the middle of, the bush, it's going to burn. And if it's plastic, it's going to cause a lot of problems. So we're looking at natural fly ash and different things that can be added to recycled products that will be fire retardant, but also UV resistant. A lot of places where they develop these products, they'll disintegrate, particularly the polyolefins. So we're looking at natural UV and natural fire retardancy as well.
Great, thank you. Any other questions? Oh yeah, we have got one more.
Thanks. I'm not sure whether nylon products or plastics, but all the gill nets that they retrieve from the oceans up near Gove, do you know if they're plastics and if anything can be done with those?
Yeah, we've been doing some work on them, and I've recently got a lot of samples from up there, and we're working with a big chemical company with a near infrared handheld device that can actually identify what they're all made from. Most of them, the gill nets are mostly made from nylon, and which can be recycled. Nylon's quite a valuable material, and a lot of the other nets, the trawl nets, are polyethylene, HDPE. Which the HDPE, if we know what they are, then we know what we can remold them at, and we know we can process them. So we're looking into working with them later in the year in the Gulf as well.
Great. Oh, there is one more again.
Just some suggestions for products that councils might be able to use. Bollards would be very useful. We're using bollards a lot.
Yep.
Anything that would be useful for traffic management to replace concrete parking slabs and particularly to keep cars from driving through, like to cut corners on roads. We need to put something around the road to control where the car goes. What about traffic signs, like speed signs and to replace the steel sign? If you could make like a traffic sign, a parking sign, a speed sign, those sorts of things, would that be feasible to make out of the plastics that you're developing?
Yeah, absolutely. So I think we've been looking at that's one of the things that we're about to do is go through sort of lists of things that council, do buy and what can be replaced, what could be extruded, what could be compressed mold. So the signs, I think, I'm trying to picture what they look like, but I imagine that would be a compression molding style thing, depending on how big they are. Are they the sort of like the triangle signs you're talking about?
Yeah, so that she can't hear you unless it's through the microphone, unfortunately. So I'll relay, like stop signs, street signs.
Yep.
Did I miss anything there? Yeah.
Yeah, definitely. Yeah, that would be you'd grind the material up. Polypropylene, polyethylene would be quite suitable as long as it's got that UV resistance. And then you do a compression mold out of it. So the simpler the product, the simpler the shape, the easier it is to make. Once you start to get into sort of different levels of design, it may be looking at different manufacturers that have specialized injection machines or, roto molding for sort of some of the larger things. But for all the extrusions and small sort of shape things, yeah, that can be made through different molds that would go into a compression molder.
Well, thank you very much, Louise, for answering all those questions and for the presentation. If everyone wouldn't mind putting your hands together and thanking Louise.
Thank you.
Take care and have a lovely weekend.
Okay. Thank you.
Cool.
Bye, everyone.
Great.